Now let's go through the history of WebRTC. Okay, so the intent of showing, or walking you through the history of WebRTC is to make you understand why WebRTC is built like this. Okay, we'll go through the sequence of events that had happened in the past, which led to the invention of WebRTC technology. Okay, if you're not interested in the history, you can skip this video. It's totally fine. But yeah, um, just knowing the history, you might find it a bit fascinating or informative, make you feel it bit interesting. Okay, so let me start the sequence of events that had started. Okay, so what happened in October 1992? Okay, this person, Ron Frederick, he started experimenting with this tool. Okay, and he was trying to build his own tool, which later on called NV. It is a network video conferencing tool, as you can see here. Okay, and it was inspired by another audio conferencing tool. During his childhood, he used to see some communication channels where people would communicate with each other through text. Okay, and those text channels were like a channel, right? Multiple people were part of that channel, and uh, whatever you post in this space or this channel, everybody else will receive that information, right? So it was kind of multicasting. Okay, so he thought, why not build a network video conferencing tool which would allow to do the same thing, but not for the text but for the video, right? So in the early 1992, in the November itself, the NV tool was released in binary form. Okay. So the software is released for the public to use, and it was used widely. Many companies used it, and here you can see the metric, like 200 subnets in 15 countries. It became so popular that time. Okay, and then later on, the same code next year, here you can see the source code of NV was released. All right, so and then again later on it added some weblet based compression and color support, right? While working on this system, okay, this NV tool, there were some challenges at that time. The bandwidth of the internet at that time, it was not that great, right? So now we have very wide range of very good bandwidth of the internet. We have very fast internet. That time it was not there, right? So a good compression algorithm was required, okay, to build a tool like this NV. Okay, nowadays also, in order to make a good video conferencing tool, you still need compression. Even with the great internet connection, it's not possible to achieve those video conferencing capabilities that the way we want nowadays, with the great quality without the compression. That's not possible, right? So compression is still needed, and at that time it was like, you can't move without the compression at all. Okay, at that time there were few tools. Okay, there was some proprietary tool which used to do the compression, because there existed few tools which people were using for video conferencing. Those were proprietary tool, and those were not just restricted in terms of software, they were restricted in terms of hardware as well. So the compression algorithm there they had was based on the hardware as well as software. So you needed this hardware. On top of that hardware, you had to run this software, then only the compression would work, because whatever signal signaling you were getting, the audio or the video data, and those samples were getting compressed and decompressed while coming in and going out, right, at the hardware level itself. This tool, NV, using this tool, Ron Frederick was trying to solve this problem, where you don't need a proprietary tool. Okay, you don't need a proprietary tool in order to achieve this compression. What he wanted, what if that compression can happen at the software level itself while going out, and while coming in, the same data, okay, could be decompressed and played, right? There were a few challenges that he faced during that time, because the hardwares that were available at the time, you would receive multiple channels, multiple streams of data, media data, but you cannot play all of them at once, right? Nowadays we can play multiple audio or video at the same time on our machine, but that time it was not available. So he had to do some mathematical calculations here, where he would have to take this these streams, and those samplings would see, in order to manipulate those audio and video information and do some mathematical calculations. First, there was this thing which was available on the hardware level, where those signals could be digitized from the hardware. You can receive that digital information, and in the binary form, right? And then your software can perform whatever operation it wants on those data, right? So he had to do some mathematical operations on that, and using that he would have to combine these data and play them as a single stream. Okay, so that way it will feel like, okay, what you are receiving multiple audio, and then you are playing, like it will be like multiple people are talking at the same time. Okay, sometimes more than one person or more than two people can start talking at the same time, and you want a real-time experience, right? Like it's actual conference, so you will need those facilities, right? So there are a few tools and softwares available at that time, but then all of them were dependent on some hardware, or they were doing things in their own way. Okay, so people were facing a lot of challenges, because if you are using this algorithm or this way of doing thing, you have to do it this way only. Many people or many companies were trying to solve this problem, where they can communicate over the video conference. Okay, but everybody had a different approach of doing that. To solve that problem, they started thinking about, what if we have a protocol which is standardized, and the same protocol could be used on every system. So even the cross software, like currently suppose you have Zoom, and then you have Google Meet, you have WebEx, these softwares, right? If they want, they can talk to each other easily, right? Because underlying infrastructure, protocols, not infrastructure, but the protocols are same. They all can send the RTP packets to each other. So that way, if they want, they can make it happen, and it will be easily doable, right? So that led to formalizing of RTP protocol. It came with another protocol which is called RTCP, which is its companion protocol. It handles the congestion and all sort of metrics related to the RTP packets. That time internet was not that great, and there was some issues like this added a little bit complexity, and the people were not very much liking it. So use of RTP declined a bit, but then again some refinement happened with this RFC. Okay, it was started with 1889, then some refinement happened, and then now this and this RFC, you can see 3550 and 3551. These are the staple ones. You can still find it, and this is the what RFC currently used by the RTP standards as of now. Okay, and then after some time, NV tool, it was evolved. It started providing expanded platform support. Many people started using it. Even NASA started using it for its shuttle missions, broadcasts. Okay, it allowed hardware codecs integration, right? So what I mean by codec, so earlier we discussed about the compression algorithms, right? So these codecs are what allow you to compress or decompress those media data. Okay, but the way they compress those data could be different, right? So that is the job of this codecs. Okay, it means coding, decoding. Okay, coding and decoding. So here you will code it, encode it, and here you will decode it. While sending out of the machine, you will code it so that if it is this big file, it will become this much. Okay, so that it can be easily sent over the wire, over the internet, right? So it started supporting these codecs and integration. So it was not restricted to, like, if you have this codec, you can only use this codec. No, if you have some other codec, feel free to use that. Okay, and then there was this another tool, CUCME. It started allowed interoperability with the CUCME tool as well. So yeah, that happened, and then slowly it was the last release was this only, NV 3.3 beta, and then 4.0 alpha existed, but it was not completed because the original author Ron Frederick got involved in some other work, and then whatever version was there, people were still using that. And this NV tool, it also inspired other projects. Okay, and like this, your place where it was acquired by Microsoft at that time, and then many things were happening at that time. Okay, so during those time, people were mostly interested in the multicast. Okay, where you send some data and it should be received by many people, right? So it was like that. People are not thinking about what if we build something where two individuals can communicate, right? During that time, they were not thinking that much about it. RTP researchers, people who were working heavily on the RTPs, got involved in a project which was called MBONE, multicast backbone. It allowed efficient many-to-many streaming without replicating data per user. And then adoption waned, means it became less popular because unicast, TCP and HTTP streaming became dominant. Okay, despite it was inefficient, because TCP is not very good for streaming data, right, or real-time communication. Later on, people started adopting UDP. It came, and then RTCP's complexity we already talked about. So it was a bit complex, so people were not that much interested. But then using RTP, what all you could do. So the original author, he did this game. He made multicast version of Space War, where multiplayer could use this protocol. This game could use this protocol. So similar approaches could power shared whiteboard and BitTorrent style distribution. So all those things were possible with the RTP. Now all these things were happening. Then what happened suddenly? There was this company Maratic. Okay, its co-founder, this person Sergey Lachapelle, I hope I'm pronouncing his name correctly. So during his college days, I think he was working on some project, and real-time project. Okay, and later on he continued his interest. Okay, so what happened? He, after his college, he co-founded this company where he was mostly working, or his team, his company was mostly working on real-time communication or real-time conferencing softwares. Later on, this company was acquired by Google. Okay, so there, what they did, the whole team, started, their first work was to work on the Gmail voice and video chat. Okay, so the whole team was working on this, but it was not easy task to do. Okay, and they, because this whole thing was working in the browser, right? This had to work in the browser. Browser was not that sophisticated that time, right? Even in early days, when you had to play some video on the browser, you needed to install some plugin in order to play those videos, right? Some Adobe Flash plugin, I remember, or some other plugin, whatever plugin you needed, a different software as an extension or something you needed to install in your browser so that you can play media. Okay, nowadays you can directly embed it in a video tag and it will work, right? So all those capabilities were not there in the browser at the time. So what they did, they had to use plugins like NP API. Okay, and then different tools like this. For audio they use GIPS, and for video they used video. This is another company, and this is also a different company. And for networking they use this tool, LibJingle. And all these things was led by the person named Justin Uberti. I looked about him on YouTube. You can you can simply search Google I/O events for 2012. Okay, just search with WebRTC. You will find his talk on the WebRTC when he was introducing the WebRTC. So he took the responsibility of combining all these things and make this software work. This feature, Gmail voice and video chat. Okay, but they observed some security issues with using these plugins like NP API and all. Chrome was designed with sandbox approach, right? We know that Chrome's tabs are implemented with the sandbox approach, where they keep data of each of the tabs separate from each other. But then building this software was very tedious, and it was not an easy job. So later on they started thinking about how we can make this easy. Why the HTML and CSS and all these text-based information on web open, but everything about the voice and video, all these things were still proprietary and very limited. It was not open. So Google thought of why not make it open. So what Google did, it acquired a couple of companies, which was like ON2 for video and GIPS for RTC tech, and then Google open sourced all of them for WebRTC. Okay, but if you want to make something available, it's not just like you buy some company and open source all those things and it's done. No, it doesn't work like that, right? In order to make something open sourced or a standard, you need two things, right? This IETF and W3C. So here IETF is for protocol standardization, right? So whatever network internet protocols are there, their rules are developed, standardized by this team, IETF team, and in the form of RFCs, right? So if you read RFCs, what is it. So using these RFCs, like you make the protocol and then you document all the rules in the RFCs, like these protocols are supposed to work like this. And then those protocols are made, and now you need APIs, those implementation of those protocols, right? So browser should implement these protocols, whatever protocols are required to make it work in the browser. All those protocols should be built into the browser, and made it available through the APIs. So that job is done by the W3C, right? So Google had to, or this team, okay, this team from the Maratech, they were doing this, right? So they had to come up with, plan to make this also work, right? So it was not easy. It was a challenging task, and some of the folks at Google, they were good at this. They had done a lot of, IETF work, so they approached them, and then they organized a lunch, and all engineers from, different many companies, so Google, Cisco, and Ericsson, Skype, Mozilla, and a lot of other people, okay, they came together to push RTC standards, okay. And then Harold Alvis Strand, so he was the person who drove this. He was working in the Google at that time, and he took the charge of helping the team through these things, okay. And later on he continued his work on this, and then team from Maratech was mostly, and they went back to actually work on those things, and he took care of this Harold, he took care of all these things. That's how WebRTC happened, where during this discussion, what happened, whatever problem they wanted to solve for WebRTC to work, many of the protocols already existed at that time. They needed something for the signaling, so at that time SIP was already available, and different things like socket and all, and there were many other things that could have been picked, so they picked it. So SDP was already existing, RTP was already there, so all these things were already there. So they, what they did, they picked all of these protocols and grouped them together, stitched them together, and made this WebRTC. Okay, so that's how WebRTC was born, right? So now you know why WebRTC is like this. WebRTC was not invented like a single standalone project. It was not like this. They were trying to solve a problem, and they didn't have a standard. Different people were using different technologies, different protocols, and they wanted to solve it once and for all. And they thought, okay, we should have some standard, and on top of that standard, everybody should build their software. Okay, so we should not go and reinvent the wheel. Suppose one person is working here, again he went to the other company, again for similar thing, he again has to work on some different thing, right? Again he has to learn and do a lot of other research. So it was messy. So they wanted to fix this core things, and then on top of that you can build whatever you want. Okay, and WebRTC is not limited to audio and video or messaging. They provide a lot of other things you can do, you can achieve with this. You can build games also. Okay, so using all the existing technology, they made the WebRTC, and in the present day, the WebRTC is widely used, very widely. So Google Meet, WebEx, then Zoom, then Microsoft Teams, they're all using this technology. They're all using this WebRTC. Okay, I don't know what future has, but yeah, there will be some things like say noise suppression. This is something nowadays, or currently many companies are implementing their own noise suppression, because earlier these softwares were being built for multicast, and common people were not using it that much. Okay, nowadays everybody using it, right? For one-on-one calls, it's like this, and people don't have ideal conditions for those calls or meetings all the time. They can be in a noisy environment, or they can be in a place where they have to make video call, but the background is not that professional, right? So for those things, still people or companies or developers are using their own implementation, but I hope in future these things become standard, and as part of the WebRTC. So for the virtual collaboration, gaming, telemedicine, there's so many use cases. So yeah, this is the gist of what we discussed. Okay, so this is how it happened, and RTP began, and it was a foundation of real-time media transport. And then RTCP was standardized, which allowed interoperable streaming framework wherein different software could interoperate. And then this period, expansion of tools and project happened a lot. A lot of different tools and projects were being built for real-time communication, and NASA also used it. So later on there was this debate about multicast and unicast. Okay, so initially they were all focused on the multicast, but later on they started thinking about the unicast as well, right? One-on-one calls, that could also be a use case. So yeah, efficiency versus practicality. Right? So, and then Google acquires this company Maratech, and then steps towards browser native RTC, right? And then they make these protocols standardized, and they do industry-wide collaboration where they organize lunch and discuss about the WebRTC, where many companies come together and discuss this problem, and they come to a conclusion, right? And then WebRTC gets adopted and it's being used a lot nowadays. So that's about the WebRTC. So during this conference, where WebRTC standardize was happening, where they were borrowing different protocols, there are a few things like I mean, they could have built something entirely differently, but some people were also worried about this can go a bit political, because a lot of people had worked so hard on those existing protocols, and if they can be used, why do you want to reinvent the wheel, right? So with those reasons also, they picked all those existing things and bundled it together and made it part of the WebRTC.